Well, let's go ahead and start looking at the periodic table. Now, as we look at the periodic table, the thing about the periodic table is it's going to be divided into three sets or three categories of elements. And those three categories are metals, nonmetals, and metalloids. The first set of elements that we're going to look at is metals. The second group that we're going to look at is nonmetals, and then that last group is going to be the metalloids. Now the thing is, this heavy zigzag line or bold stair step on the periodic table is going to determine where each is located. If we go ahead and look at the periodic table, what I'm going to do is I'm going to go ahead and draw in this bold zigzag line. And every periodic table has this zigzag line. This zigzag line, again, when you look at my periodic table on the wall, you're going to notice again that it has that stair step or zigzag line. So what I did is I went ahead and I drew it in here. The thing that you're going to notice about this heavy zigzag line is all of the elements that are located to the left of this zigzag line, those are going to be classified as your metals. So these over here are metals. This large section in the middle is going to be metals. These down here are going to be metals. And here's the thing. This open spot, these two open spots right here, that's all of these elements down here. And again, those are going to be classified as metals. So let's go ahead and let's get back to our PowerPoint. Again, as I said before, the metals are going to be found to the left of that bold zigzag line or that stair step on the periodic table. Some characteristics for metals are going to be they generally have 3 or fewer valence electrons. Some more physical properties, they have luster, meaning that whenever a light is shined on them, they're going to reflect that light, or they're going to be shiny. When you think of aluminum, when you think of gold, when you think of silver, things like that, your precious metals, again, they're going to be very shiny, and that's luster, or that reflection of light. When you heat them up, they're going to be very malleable, meaning that we can heat them up, and with a hammer, we can go ahead and pound them into different shapes. When you think of a blacksmith, you always saw them putting that horseshoe in a fire, and then with a hammer they were beating on it, shaping it to the shape of the horse's foot. So this is the ability to be hammered into different shapes. For the farmers out there, metals, they are very ductile, meaning that they can be drawn into long, thin wires. When you think of electric fence and things like that, you're basically taking a solid metal and you're pulling or stretching it into long, thin wires. Think of a piece of silly putty. I know it's not a metal, but when you go ahead and you grab it and you start pulling on it, it gets thinner and thinner and thinner. And that's the same thing with a metal. They're going to be very ductile. Metals, they are very good conductors. Remember what we said about conductors. That means that they are going to pass energy through. And also, the other thing is they're going to be very poor insulators. What I mean by that is they are good conductors, meaning that they move energy, but they're not going to hold the energy, and that's an insulator. So they are poor insulators of heat and electricity. Most of those elements are solids at room temperature. There is one that is going to be a liquid, and that's mercury. When you look at my periodic table, you'll see mercury is in blue, so it is the only liquid at room temperature. They have extremely high melting points, and if they have extremely high melting points, they're also going to have extremely high boiling points. Some family names that I'm going to want you to know is group number 1. That's going to be with your hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Those are going to be known as your alkali metals. Group number 2, that's the one with 2 valence electrons, beryllium, magnesium, calcium, strontium, barium, and radium. Those are going to be your alkaline earth metals. Now, if you think of that name alkaline, maybe you've heard of alkaline batteries. These are a lot of the elements or metals that are going to be used in batteries. Groups 3 through 12, that's that large middle portion of the periodic table that I told you we were going to ignore when we were doing electron dot diagrams. So groups 3 through 12, those are going to be your transition metals. I want you to think about that word transition. That word transition, when you think of speech, means that you're moving from one thing to another thing. And that's really what we're going to be doing here. We're going to be moving from the metals and we're transitioning to another category of elements. The elements starting with lanthanum, number 57, and going through to number 71, lutetium, those are going to be known as the lanthanide series. And then that other one on the bottom there, going from actinium through lawrencium, that is going to be your actinide series. Group number 1 on the periodic table, again getting back to the hydrogen, lithium, sodium, and things like that, your alkali metals, those have one valence electron. The one thing that I'm going to tell you is these are the most reactive of all of the metals. Okay, so the alkali metals are extremely close to being stable, and they're really going to do whatever they have to do to become stable, and that's the reason why they are extremely reactive. When we go ahead and continue talking about the metals, what you're going to notice about a lot of the metals is they are found not naturally in nature, but what you're going to do is you're going to find them basically as a compound. And what that means is they're going to have some corrosion in them. So some of these elements are going to corrode. Now when we talk about corrosion, corrosion is just going to be the weakening of a metal because of rusting. So again, think of what happens when you rust. You go ahead and you apply a little bit of liquid to it, and specifically water, and as it combines with that water, what it does is it rusts. Now again, as we go ahead and look at metals, a lot of metals are going to be used in alloys. And what an alloy is it is a physical combination of two or more metals. If you think back to the ancient days, one of the things that they used for shields was bronze. They had these bronze shields. And really what it is it is a mixture of copper and tin. Now again, remember what a mixture was. It is a physical combination. So what they would do is they would melt the copper, they would melt the tin, they would go ahead and mix them together, and then they would pour them and mold them. Stainless steel silverware, things like that. It's going to be a mixture of chromium and nickel. Steel is going to be iron and carbon. Another thing, chrome, when you put chrome on vehicles. Thing is, it's going to be very shiny also. And the reason why we use alloys is they're used to strengthen metals. The thing is, bronze is a lot stronger than the original copper and the tin itself. Stainless steel, again, it's going to be stronger than chromium or nickel. And as it says here, they are stronger than their original metals. They don't corrode, so they're not really going to rust like some of the original metals might.